Hello everyone. Today we're gonna give a presentation on mobile IoT case study that how Asia Pacific intelligent connect to the IoT. This paper was released in February 2019. My following are the presenters Preet Mantri, Aman Vishwakarma, and myself Sanket Shinde. Over to you, Aman.
Good morning, everyone. So today, let us view our first case study, that is tracking traffic and weather conditions on mountains. So here, an IoT sensor is installed at each of the starting points on mountain to track temperature and humidity, together with number of people passing through that point. So this technology was developed by KDDI, and all the information that is tracking of temperature, humidity, and people. This all information gets available on their web portal, and enabling climbers to plan their schedule, clothing, and equipment. Like if it is summer, then they have to carry less clothes, or it is cold, or any storm is coming, they get an update of how everything gonna occur. Next slide. So here we can view that on the right hand side, this is the device which is used to track to track temperature sensors and records of everything. And on the left hand side, we can see that this is the uh, screen we get to view, or interface we get to view. That is that 327. That means there are 327 people are currently available. 24 degrees is the temperature and 65 is the humidity. So this is how we can see, and also we can see that there is a small map which tells us that at this point to this point it is safe for climbing, and further it is currently not safe. And also this has helped the local government to plan their construction works and development process through it. The next case study will be presented by my friend Preet Mantri. Thank you.
I will explain about smart fisheries. With continuous expansions of aquaculture, scale and density, contemporary aquacultural methods have been forced to overproduce, resulting in accelerated imbalance rate of environment, the frequency occurrence of fish diseases, and decline of aquatic product quality. Moreover, due to the fact that average agricultural workers in many parts of the world are on higher side, fishery production will face the dilemma of shortage of labor, and aquaculture methods are in urgent need of change. Modern IT technology has gradually penetrated into various fields of agriculture, and concept of smart fishing has already begun take shape. The intelligent fish farm tries to deal with precise work of increased oxygen, optimizing feeding, reducing diseases incidents, and accurately harvesting through the idea of replacing human with machine. The first question will arise is, what is aquaculture? Aquaculture is the breeding, rearing, and harvesting of fish, shellfish, algae, and other types of organisms which are endangered in endangered. As we can see, the Indonesian mobile operator Telkomsel is working with eFishery, a Indonesian-based startup, to use mobile IoT technology to make fish feeding equipment more effective, and Telkomsel and eFishery are jointly developing NB-IoT devices specifically designed to support this aquaculture. In August 2018, the two companies piloted a new IoT connected fish feeding solution in many areas of Indonesia. The question will arise is, what is an NB-IoT device? The Narrowband Internet of Things is a standard-based low-power wide area technology developed to enable a wide range of new IoT devices and services. NB-IoT significantly improves the power consumption of user devices systematically, capacity and spectrum efficiency. As of 2018, eFishery has supplied IoT-based smart fishing equipment for commercial aquaculture to more than 2,000 fish and shrimp ponds across 19 provinces in Indonesia. What is smart fish farming? The traditional aquaculture IoT system is a high integration of cloud technology and Internet of Things. It adopts three tier of structure. First is device layer, network layer, and cloud service layer. The device layer composed of sensing equipment such as such as oxygen meter, pH meter, temperature, salinity, ammonia and nitrogen and water level, etc., as well as on the working status of the device, and aquaculture video image information. The control equipment includes aerator, feeder, pump valve, and other equipment. The data acquisition terminal is responsible for upward transmission of sensor to the network with the help of Bluetooth, Wi-Fi, NB-IoT, and many other technology, which is responsible for data transmission between the device layer and the cloud service layer. The cloud service layer includes cloud platform and a smartphone app, which are mainly used to store and process aquaculture data and provides the various aquaculture information services. Traditionally, fish feeding has been carried out manually, but this can be expensive, inaccurate, and resulting in unprotected fish farming. Due to use of IoT data analysis, cloud computing, it reduces the cost, increases output, improves efficiency and its quality. Optimizing feeding Optimizing feeding represents the biggest challenge in aquaculture industry, according to eFishery, which estimates that its customer will make return on investments for IoT solutions in 3 to 5 years. Next, my friend, so Sanket will explain.
Thank you, Preet. So, the next case study is on smart agriculture. So, in smart agriculture, the sensors capture humidity, temperature, and the rainfall data, which is sent to the plantation manager by NB-IoT. They can use this data, which can be they can use this data which by accessed by from PC or smartphone app to find out the environmental condition, predict yield, and identify the parameters that drive productivity. This is an efficient way to obtain reliable data from a plantation in a remote location. Prior to the deployment of the connected sensor, worker had to physically visit each location to get a relevant information about the crop. However, with the with this connected sensor in place, information can be obtained remotely and precisely, enabling resources to be employed more effectively and efficiently. The extensive coverage provided by mobile IoT network enables customers to monitor large geographical area, including land cover in a deep leaves. This technology is also designed to ensure reliable data transmission. The next slide is about the strategies. So this project is implemented in Malaysia, Maxis, the country of leading communication and internet service provider. The Maxis is focused on building an ecosystem in Malaysia, which will help business adopt NB-IoT solution. To that end, it has established an IoT innovation lab in Malaysia that act as a bridge between Maxis enterprise customer and device manufacturers and solution provider. The faculty serves as an experimental showcase where Max's enterprise customer can see demonstration of the fully tested solution. For the customer with the necessary technological capabilities, the lab provides access to the live NB-IoT technology for testing purpose, thereby reducing the time it takes to ready a new solution for a commercial deployment. The application is tested in the lab, including agriculture, soil and water measurements, smart utilities, water and electric, asset tracking, and smart parking. Among other Maxes also plan to certify devices and solutions tested at the lab and compatible with the Maxes network to make it easier for the business to adopt the technology. The presentation is concluded by the Preet.
Thus, we have discussed case studies of IoT applications in our presentation that will help us in with the help of different IoT devices, cloud computing, and data analysis. In different sectors, we can automate it to improve its efficiency and increase its output and quality, and also reduce its manpower. And I would like to conclude our topic with mobile IoT devices will change not only business process but also business models and daily life. Thank you.